Hello friends, welcome back to my channel. Today I would like to share with you the concepts from atomic structure and the periodic table. All substances are made of tiny particles of matter called atoms, which are the building blocks of all matter. Each atom is made of subatomic particles called protons, neutrons and electrons. The protons and neutrons are located at the center of the atom, which is called the nucleus. The electrons move very fast around the nucleus in orbital paths called shells. The mass of the electron is negligible, hence the mass of an atom is contained within the nucleus where the protons and neutrons are located. As you can see here, neutrons and protons are inside the nucleus and electrons around the nucleus. The relative mass and charge of protons, neutrons and electrons is mentioned over here. Proton relative mass 1, charge of +1. Neutron mass 1, charge 0, neutral. Electron mass 1/1840, charge -1. The proton number is otherwise called atomic number, which is the number of protons in the nucleus of an atom. The mass number, otherwise called nucleon number, is the total number of protons and neutrons in the nucleus of an atom. How to write a nuclear symbol? To write a nuclear symbol, the mass number is placed at the upper left of the chemical symbol and the atomic number is placed at the lower left of the symbol. The complete nuclear symbol for helium is drawn below. 2He4, 2 represents the atomic number and 4 represents the mass number. This is an example question. How many protons, electrons and neutrons are present in 19 potassium 40? Atomic number equals number of protons equals 19. For all atoms with no charge, number of electrons equals number of protons. Therefore, electrons number is equal to 19. The mass number 40 is the sum of the protons and the neutrons. To find the number of neutrons, subtract the number of protons from the mass number. 40 minus 19 equals 21. What are ions? Ions are charged particles formed when atoms or groups of atoms lose or gain electrons. Positively charged ions form when electrons are lost. Negatively charged ions form when electrons are gained. The charge on an ion is shown as a superscript. For example, an aluminium ion Al3+ carries 3 positive charges. It forms when an aluminium atom loses 3 electrons. The atomic number of a chloride ion is 17 and its mass number is 35. Calculate the number of protons, neutrons and electrons it contains. Number of protons equals 17, number of electrons 18, number of neutrons also 18. Electronic configurations. Accommodation of electrons in shells or energy levels is called electronic configuration or arrangement. Electrons are in orbit around the central nucleus of the atom. The electron orbits are called shells or energy levels and have different energies. Shells which are further from the nucleus have higher energies. The shells are filled starting with the one with lowest energy. The first shell can hold only 2 electrons. Second and the subsequent shells can hold 8 electrons to give a stable noble gas arrangement of electrons. When reacting, all atoms will try to acquire this perfect arrangement of electrons, that's having the maximum number of electrons as possible in their outer shell. Therefore, all atoms try to have 8 electrons in their outer shell. Unless they only have 1 shell, then they will try to have only 2, because this is the most stable arrangement. Noble gases have 8 electrons in their outer shells already, except helium, which has 2, making them very stable, so unreactive. As you can see here, the nucleus at the center, which is made of protons and neutrons. The first shell is the lowest energy level, which contains 2 electrons. Second energy level contains 8 electrons, and the third one, 8 electrons, can fit into this level to give a stable arrangement. These are the electron arrangements of the first 20 elements, from hydrogen to calcium. The symbols is mentioned over here with atomic number, and the electrons in the first shell, second shell, third shell, fourth shell, and thereafter electronic configuration. The last or the outer shell is known as the valence shell, and its electrons are known as valence electrons. These valence electrons indicate the chemical properties of an atom or element. Atoms having the same valence electrons have similar chemical properties. The number of shells of an atom represents a period. The columns are known as groups, and there are 8 groups in the periodic table. The number of outer electrons in the valence shell indicates the group. This means that all the elements or atom in the same group have similar chemical properties because they have the same number of valence electrons. What are isotopes? They are the atoms of the same element which have the same proton number but a different nucleon number. That means different number of neutrons. Example: isotopes of hydrogen, protium, deuterium, and tritium, 1H1, 1H2, and 1H3. Most hydrogen atoms have just one proton and one electron and lack a neutron. These atoms are just called hydrogen. Some hydrogen atoms have one neutron as well. These atoms are the isotope named deuterium. Other hydrogen atoms have 2 neutrons. These atoms are the isotope named tritium. Isotopes have the same chemical properties because they have the same number of electrons in their outer shell, and the number of electrons in the outer shell is responsible for chemical reactions. They also have the same number of protons, so are still considered as the same element. 2 types of isotopes are radioactive and non-radioactive. Medical and industrial uses of radioactive isotopes. Under medical uses, sterilizing equipment and tracers. Industrial uses, smoke alarms and tracers. How to calculate relative atomic mass? The relative atomic mass of each element is calculated from the mass number and relative abundances of all the isotopes of a particular element. It's done by this equation: sum of isotopic abundance times isotopic mass number over sum of isotopic abundance. An example is shown over here. This table shows the mass numbers and abundances of naturally occurring copper isotopes. Mass number and abundance is mentioned here. How to calculate relative atomic mass of copper? 63 times 69 plus 65 times 31 over 69 plus 31, which is giving you 63.6, which is the relative atomic mass of copper. That's all. Thank you so much for watching this video.